Today we are at one of the most exciting startups in Europe. This is Mimic. Let's take a look at Mimic Robotics and what they're building.
Yeah, sure. We all met each other in the software robotics lab back then in ETH, coming at it from different perspectives, different angles. We wanted to do this company. We wanted to work on manipulation. We wanted on hands and AI models.
So what we have in front of us is one of our robot stations. So this is a stationary robot station. It's made up of a table that houses all the driving electronics and the compute for it, and two robot arms. So this is actually made here at Mimic. This is a humanoid robotic hand with somewhere between 16 and 20 degrees of freedom, depending on how you count. Now, these hands are made to perfectly well mimic the degrees of freedom a human has to allow us to completely match the commands of the teleoperator to these bad boys right here and allow us to do precise motions like inserting these fans.
But beyond the hardware itself, what is the core mission behind Mimic? What are they really trying to achieve?
We build AI models that tell robots what to do next and allow them to autonomously move their hands to solve all kinds of tasks in the real world.
To tackle such a complex challenge, Mimic relies on a secret sauce to unlock true robotic intelligence.
This paper is titled Mimic Video, and it's basically a new take on VLAs. Insofar that VLAs use vision language models and then kind of specialize these vision language models to be robotics models. We thought, okay, this is cool. It's actually a very nice and scalable recipe, but there's probably a better choice to start from in terms of model compared to a vision language model, and that was video models. Video models really, they have by design to be able to predict the future of dynamics, right? And that's why it fits much better.
But what exactly is the tech stack powering this level of processing?
We use the NVIDIA Cosmos model for this paper, and that's one of the first examples that we are aware of of actually making this work. So it was pretty cool to show that you can create a robot foundation model that's based off of a video model backbone as opposed to VLM backbone.
And what are the tangible benefits of this approach compared to traditional methods?
If you can provide ground truth video of what would happen if the robot did something, then your success rates skyrocket immediately.
One thing I find particularly compelling about Mimic is the interdisciplinary team driving this robotic powerhouse.
I was studying mechanical engineering in Aachen at WTH, and I was looking around for what's the coolest master degree to do. And I applied for two different programs actually. One was mechanical engineering and the other was industrial design, just because I thought it was a really cool topic and it could give you a broader overview of the entire development cycle of a product. So I couldn't really make a choice at the time, and I was just like, all right, I'll do both. But I felt like it was, at the time it seemed like a good idea, right?
Their diverse backgrounds and unique way of thinking are what allows them to remain so deeply customer-focused throughout the journey.
I always see myself as kind of the glue between technology and the customers. I originally started off with doing a lot of the customer conversations here at Mimic, and then moved more and more into product development, kind of bringing together customer requirements and understanding the tech, and kind of bringing both together.
I think by now there's a good understanding for sort of the relevance of AI in the field and the new possibilities that it allows you to do things on a different level of complexity than before, right? And the thing that we really have to explain is the difference between seeing a robot move that was programmed to go to position X, Y, Z, and seeing a robot move that autonomously generates that entire trajectory without a single line of code that's dedicated to that path. And this is something that is easiest if you just demonstrate it. So a lot of times we show people examples of a robot doing stuff on a similar task or even on their tasks that they're looking at, and that is, I think, the best education for people to probably understand the value add of the autonomy, right? That you can react to different positions of objects, different orientations. What happens if you're dealing with different variations of an object you have to deal with, or entirely different classes?
There are a few reasons why they've chosen Zurich as their home base. First, they all come from ETH, one of the top universities in the world. But also, manufacturing is deeply rooted in Europe, and maintaining close contact with customers is essential.
If you kind of draw a circle, maybe 400 kilometers or 500 kilometers, you'll find billions in manufacturing, right? In just companies like, especially Germany, but also like Northern Italy, in France, is crazy, right? Like the amount of just manufacturing or assembly use cases that we have access to from here. We talked about servicing, right? Like making sure that these robots actually run reliably. You can only do that if you're close to your customer.
While this proximity to the European market is a significant advantage, there are still differences in how Europe and America approach scalability. This led me to ask, for a company with such a massive vision for growth, where do they see their place in the world? And does Zurich remain their long-term home for the future?
That's a good question. I think if you want to think globally, as a startup, you shouldn't even think in those categories, right? If we have the right talent here to do R&D here, then this is the best place to build it. If manufacturing is most efficient in Asia, then we should be in Asia to do our manufacturing. And be wherever our customers need us, right? Wherever we have to be for them.
You know, people are sometimes, I think in Europe there can be the impression that especially bigger corporates, they move slowly, right? But my experience now has been that the relationship is just different, right? So I have made extremely positive experience now with just learning from the corporates and the openness of the corporates here in Europe to teach us how to bring a product into their productions.
We're in a position where we can compete at building frontier models, right? And combining those with sort of the hardware expertise that's necessary and do it much closer to our customers. We're very much focused on getting robots with proper generative models, right, out on the factory floor as fast as possible.
Like, it's unbelievable the speed at which it's moving right now. Right? I really strongly believe that until the end of this year, you will see these robots in factories, right? Like actually doing meaningful work 24/7.
And there's a good window of opportunity to build a proper robotics hyperscaler or robot learning hyperscaler here in Europe, and that's what we're trying to do.